Hello, in this tutorial I'm going to create a parent class for all of our custom custom PCG nodes that we want to create to make it easier in the future to get started with the process, and so that we don't have to repeat the same steps over and over again. Because if you want to make a basic loop that takes input points and output points, then you can do a lot of stuff in advance, so you can jump right into the important parts of it. To get started with this, we are copying one of the existing nodes that already exists, and this is very simple. To do this, we need to go to settings and then show the engine content. And if we go to the engine content folder, open it up, go to plugins and the procedural content generation framework, this one, and then to blueprint elements. There we have the set point caller node. We're going to duplicate this one because this is a very simple node that we can just reuse most of the stuff in it. And we are going to move this to one of our folders, or to a folder we want. Let's make a new folder for it. New folder, PCG tools. And into this folder, we are going to move this set point caller node. PCG tools, move here. And we are going to name it to BPCG loop base. Or point loop base. Point loop base. In this node, I'm going to explain a couple of things that we copied over from the original node. The first thing is over on the right side here, if you click on class defaults, and it's this checkbox, the expose to library checkbox. This controls if this node appears in the list on the left side, if we have a PCG graph. And we don't want this for our parent class because this doesn't contain any logic or any logic that we need for the node to function, and only the basic framework for it. And we set the category to custom, so all the nodes that inherit from this appear under the custom tab in this list. Another thing worth noting is that this node already has a custom input pin and custom output pin, which is of the type point. By default, it only has a default input pin and default output pin, but we want this node to work with points, so we are happy with the settings that we copied over to be a point, and we also want to allow multiple data sets of points. So we have a more generic node and are not limited to only one data set. Over here, there's nothing that's different from the defaults. So we can go into all the functions that exist. First, we're going to delete the point loop because we are not needing it for our parent class, since each child implements this by itself. So we delete this, and we also delete the node title override. This controls how the node, what's the name of the node if we drag it into our PCG graph. For example, in this case, we didn't override it, so it's called BPCG wall stacker, but we could override it to just say wall stacker if we drag this node into here. But we are not going to need this for our base class, because we're never dragging the base class in our PCG object. And in the execute with context loop, there happen a couple of things. First, we get all the inputs of our custom node, which, as you might remember, are these inputs here. So one input for each data asset, since we allow multiple data sets of points. And here we are converting this to spatial data, which is something that contains, I don't actually know exactly what this does, but it basically contains some information that we need to create points. This could also be an actor, the actor we currently have, and then it would be the actor position of the point. But in our case, we have points, so we break this to the tag data and then convert the data to a spatial data, and then turn it into a point that we can turn it into our loop. This stuff essentially is something you could repeat and that we want to in the parent class. And here we add all the output data to the output data so we can output it like this. The important stuff about this node is the point loop here, because this is a function where our custom logic happens, and there are multiple types of loops that we could use here. There's the point loop, which takes input points, modifies the points, and outputs the points again with the modified data. There is the variable loop, which can do pretty much the same. So it takes input points, but it can also output multiple points. So it's not limited to modifying the point and outputting the point, but it's capable of copying the point and creating new points. For example, this is what I used for making the wall stack, because we took the base point and we multiplied this point by a certain amount. And yeah, another node that we have is the iteration loop. This one is somewhat similar to a variable loop, but it does take in an input point. What it does is it takes, just like a normal loop, maximum number of iterations, so this would be your last index of the loop, and repeats what happens in this node by this amount. One thing worth noting is you don't input a point data into it. Instead, you input the number of iterations. And this is, for example, used for the grid generator, create points grid. If you open this up, then it uses this iteration loop, where it first calculates the index, the maximum index based on the settings of the node, then inputs it here and creates, and then it creates the points based on the location of the actor that this PCG graph belongs to. So it doesn't take a point as an input, but instead it just does something from the actor position or the world position. In our case, we are not going to implement this because I want to mainly focus on creating nodes that take inputs and output inputs. And as you might have seen here, you need to do a little bit more stuff to actually get to the point of using the node, because you need to either pass in the number of iterations or you need to calculate it in this execute with content. And as for the nested loop, I'm also not going to implement this because it also needs a lot of stuff in this execute with context function. And this is essentially used to loop over the input points and also overall, and then it also loops over all the secondary input points for all the first input points. This is used in the copy points node, copy points, and this one, which is a C++ node, but you can also see the old blueprint version of it in the deprecated folder, which if you go to the plugins folder of the engine, here we have the copy points node, and yeah, it also does a lot of stuff in the execute with context that we cannot implement in one parent function. We could make a parent function exclusively for the nested loop, but I'm not going to do that here. If I need it, I will make a video for it. And the same goes for the iteration loop. We don't need this. And yeah, so we are left with a variable loop and a point loop. For our parent class, we can make it so that we can either use a variable loop or a point loop because they need exactly the same setup. So what we're going to do is we are going to add a variable that is called use variable loop, which is false by default. And then we have a branch that takes this variable loop, and we are going to connect this point here. And if we are going to use the variable loop, we are going to use the variable loop and otherwise the point loop. In here, we are going to promote this to a local variable. So we have a little bit of cleaner code, which is our data. Then this one, then both of these nodes set the data to be whatever they return. And in here, let's move this a little bit around so it looks nicer. We are going to add a sequence node, sequence, which first does the variable loop, sets the data, and then once it's done, it continues down here and sets the actor data, adds it to the array, and for each loop we have the return node of our whole graph. And one thing we need to do is we need to get our data and connect it to wherever those two pins went. So here and here. And that's all the setup we need to have our parent node. Once we connect this up. This one here. And yeah, that's everything done for this. As to why we did all of this, this now allows us to do the following. We can now create a new blueprint of our point loop base. And call it, for example, rotate point. Rotate point. 45 degrees. And now the only thing we have to do is make sure that we use the correct function, which in our case is the normal loop, so we don't need a variable loop. And then we need to override the correct function, which is the point loop body. Now we can simply get the point, break the point, then set the members in the point, set members in point, and we are going to set the transform of the point and to be the transform rotated by 45 degrees. So we break this, and then we make a transform, make transform, or just the same, and then we are going to combine the rotators, combine rotators, 45. Put this in here and return the point. Hit compile, save, and if we also, if we go back to our node, we need to set it to expose to the library because we want this node to appear in our blueprint. So hit this, compile, save. Then we see the rotate point 45 node here, and we can just drag it in. And it will do whatever we did here. So it, it rotates the walls. In this case, it rotates the walls over to this position. So it does something. Not sure if it does the correct thing right now, but yeah, that's the idea behind why we did all of this. So we have an easy time of just modifying the loop body instead of doing the XU with context every single time. Yep. So I hope this helps and helps for the future, and bye.